Hi everyone, today we're starting trig identities, okay, and we're starting with 4.1, which is factoring trigonometric expressions. So the first thing that we want to talk about before we start is this equivalent here, that sine of x squared is the same thing as sine squared x. Okay, that's going to come in handy when we start to factor these expressions. Okay, so the way that we're going to do this is with something called a U substitution. Okay, so essentially we pick out the trigonometric function in the expression and we're going to make a substitution using a variable u, which is going to allow us to just have a more simplified expression, and it's going to make it easier for us to factor. So we're going to look at our expression and determine, well, first, if, change my color here, if we have a trig function squared, so we want to apply the equivalent to that. So remember, sine squared x is the same thing as sine x squared. Okay, so written this way, we can see, well, our trig function here is sine of x. So we're going to make our u substitution. We're going to say let u equal sine of x. So in your work, we do need to see this u substitution. I need to know, what are you putting in place the u with? Okay, so this is really u squared minus 1. Okay, drop the parentheses. Well, this is a lot easier to look at and to try and factor now. So u squared minus 1, we know that this is a difference of squares. So this is u minus 1, u plus 1. And then what we're going to do, now that it's fully factored, we're going to replace our u substitution back with our trig function. So sine of x minus 1, sine of x plus 1. Okay, so that's our factored trig expression. Let's try some more. Okay, so I see that I have a cosine squared x, so the same rule applies. Cosine squared of x is the same thing as cosine x squared. So I'm going to rewrite that. Okay, and being written that way, I can very easily pull out my trig function. So let u equal the cosine of x. Okay, so we're looking at 16 minus u squared. Well, again, this is difference of squares. So 4 minus u and 4 plus u. Okay, once it's fully factored, just make sure you remember to plug your trig back in. So 4 minus the cosine of x, 4 plus the cosine of x. Okay, fully factored. Alright, so maybe we're a little bit more comfortable now. Okay, and go right into things. So I'm switching out sine squared x. I'm making my u substitution. You have to replace u for all of the same trig function. Okay, so we're going to factor our trinomial. Alright, so u minus 8, u plus 2, and replace with sine. Okay, and that one is fully factored now. All right, one more of these. So I have two trig functions. Okay, so we're going to have to make two substitutions. So we'll let u equal something, and then we'll say, how about w? Okay, I don't like to use a v. It's a little too similar to the u. So either u and w could be either trig function. So we have a sine, and then we have cosine. All right, it doesn't matter which is which, but I'm going to make sine of x my u and cosine of x my w. So I get u times w minus w. So how am I going to factor this? I'm going to use a GCF. So I'm going to take GCF of w out. So I'm left with u minus 1. Okay, that's as factored as I can get. So I'm going to replace now. Cosine of x. Oops. Sine x minus 1. Okay, so for every trig expression, every trig function that you have, you're going to make a separate substitution for it. So you can have more than one. Okay, so now we're going to use this u substitution to simplify rational expressions that are written using trig functions. So we're going to do the same thing that we were just doing, except now there's going to be some simplifying. So I like to swap this out before I start my sine squared x. So let u equal sine of x. So u squared minus u over u. So remember, you have to factor before you can cancel. So in the numerator, I'm going to take out a GCF. Okay, and now I can cancel the u on the top and the u on the bottom. So we're left with u minus 1, which is really sine of x minus 1. Okay, so the same rules for simplifying rational expressions still hold. Okay, we're just doing a u substitution in the middle so that it is a little bit easier for our eyes to look at the problem we're trying to do. All right, let's just do a few more. Okay, as you do more of these, you're probably getting more comfortable. You might not necessarily have to rewrite this as cosine x squared. You might be able to go right into let u equal and then replace that. So the top, I have difference of squares. The bottom is not difference of squares. The bottom is just GCF. Right, so I can cancel a u minus 4, so u plus 4 over u. Okay, and then we're just going to replace our trig. And that's my simplified expression there. Okay, we got one more, a little bit more challenging. So I see a tangent and I see a sine. So I'm going to let u equal tangent of x, and I'm going to let w equal sine of x. Okay, in the numerator, I'm going to take out a GCF of u squared. And the bottom is actually a difference of squares. Okay, so these ones will cancel. So a u squared over a u plus w. When we plug our trig back in, we want to make sure we write tangent squared of x. Okay, that's the more simplified version. Over tangent of x plus sine of x. Okay, and that is our simplified function. So pretty easy topic here. Okay, we already know how to factor and simplify rational expressions. We're just making a substitution to pull out our trig function, make it a little bit simpler to look at. Okay, so again, you do have to show this u substitution. You do have to use this u substitution. Okay, so this is the new skill.